right, very quickly, somebody tell me what your final answer was, Jenna. No. Somebody else tell me their answer. Yes. No. Yes. X squared minus 9. That is correct. If you use your first, that is x squared. If you use your outside, you have minus 3x. If you use your inside, you have plus 3x. And if you use your last, you have negative 9. What do you notice about these two inside terms? They cancel off, so you're left with x squared minus 9. They are going to cancel off because if you notice these two binomials, they use the same term for the first and last within each one. The only difference is I have one as a plus and one as a minus. That's called the difference of squares. Okay? What would you get if you had this? Very quickly, I want the answer. I want it from the time I count down from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, stop. I need an answer. What did you get? What did you get, Avery?
X squared minus 42.
Nope, not 42. What did you get, George? Minus 36. What are you noticing? How am I getting this first one? I'm multiplying the two first ones. How am I getting the last term? Multiplying the last term. How do I know I do not have any middle terms? Because they're the same and one's a minus, one's a plus. So very quickly again, tell me, what you get here. Yes. So what do you get when you have a positive times a negative? Very good. Okay? When you see a difference of squares, you really shouldn't have to do FOIL. You can if you need a backup because you've forgotten. But because your terms, okay, are the exact same except one has a subtract, one has a plus. Your terms are exactly the same. A and A are the same. B and B are the same. You know you're going to square the first one, you're square the last one, and because it's a difference of signs, you're going to have a difference of the squares. So, yes, because what's a positive times a negative? Is any time I am ever going to multiply a positive times a negative ever going to be a positive? No. So therefore, it is always going to be a difference of squares. So it's going to be the subtract. So now here's my question. If I was to give you this, can you tell me the two factors that make that? What? Yes. How did you know it was 4? Okay, so what you have to do is you have to think, what is this? Okay, if I take the square root, that's still x, and it's still square. I've got to think of the square in there. What if I take the square root of 16? What do I get? 4. So that means 4 squared, right? There's the two terms that I'm going to use. X and 4, x and 4. And because they're a difference, one's going to be subtract, one's going to be plus. So no matter what I have, what if I have 25x squared minus 36? First thing you need to think of is, what is the square root of this?
What's square root?
Your square roots?
I don't know what that is.
Y'all should have done square roots last year.
We did.
I'm sure you have. What number times itself will give you 25x squared? What number? 5x and then 6, correct? So now my two terms are going to look like what? There's your difference of squares.
What happens if one of them is a square and can have a square root?
then you're not going to be able to use difference of squares. That's the key to tell me that I'm going to be able to break down this way. And probably what you need to do is just pencil right underneath, what is the square root of this? What is the square root of that? Okay? And if they're both a perfect square, then I'm able to use the difference of squares. But that's the key. They've got to be a perfect square. Because if they're not, then you're going to have to see if you can factor some other way. Now, sometimes right now, you're not going to be able to. So let's say I had 25x squared minus 30. Okay? Well, this would break down as the 5x squared, correct? 30, can that break down into anything perfect? No. So at this point, I'm not able to use my difference of squares. But, let's go back to the original. Is there anything I can factor out? Okay, so let's factor a 5, and that gives me 5x squared minus 6. Is this a perfect square anyway? No. Is this a perfect square anyway? Anything else I can factor out? Okay, so that's probably going to be the smallest form that I can do right now of factoring. Okay? And we're going to get to another method in a couple of more sections that we're going to be able to use a different method to actually factor that down to a number. Okay? But right now, that's where you would have to stop if you had something like that. Okay? Alright. What about this one? Everybody do this one very quickly on your paper. Elijah, tell me what the term here is going to be if I was to square root 16a squared. 4a squared, okay? Ethan, tell me what this is going to be if I was to break that down as a square root. 3b squared. Alright, now Lauren, tell me what the two terms are going to look like. Lauren? So what's the next step going to be?
4a minus 3b, and then 4a plus 3.
Very good. Any questions on that? Okay. First thing, make sure they'll break down, and then once they do, then you can write your two terms. No, you could add plus first. You could add 4a plus 3b and 4a minus 3b. It doesn't matter. Okay?
Is that all?
What about this? What?
All.
Is that all?
Yeah. It's like all two. Yeah.
That's all to that, yeah. Now we're getting a little bit harder.
Is there more?
Oh, we can always go harder. We can always go harder. Oh, we are right now.
What?
Okay, what's the difference in this versus what I just did a minute ago? I've got a power of 3. Is there anything I can factor out to result that to go down to a 2? Is there anything these two things share in common that I could factor out? X. If I was to factor out an x, what's left? Alright. Now I've created something that we had just a second ago. Look and see. Can 9x squared break down into something else? What? 3x squared. And what about 4? 2. It's a difference. Okay? So then, what's my answer going to look like? Okay? That x that I factored out at the beginning just kind of hangs out there and it gets multiplied back. Okay? Now, Avery, what was your question? Because this is all multiplied. So it doesn't matter, okay? This would be like me saying 2 times 5 times 4. Would you agree that that means the same as 5 times 2 times 4? Okay, they're all being multiplied together. Now, the only thing is, within here I have another operation within there. Okay, so that doesn't mean that x is only multiplied by this. It's actually multiplied by both. Okay, so it doesn't matter if you put the x at the end or x in the middle. Okay, but I factored it out first, so I just kind of keep him hanging out in the front. Okay, but they're all being multiplied together. Do this one. See if you can come up with this one. And I want you to wait, I wrote that wrong. Don't write it. Yeah, I rewrote that whole wrong. All wrong. I did it again. This is a brain teaser for just a moment. Shouldn't be. Shouldn't be. Okay, I'm going to pause this because I want you guys to scribble for just... Alright, what was the hint? Anybody get an idea when I said hint? Okay, how am I going to factor out a b? Okay, are you saying I'm going to factor out a b squared from both terms? Can't take out a b squared from both terms because 16 doesn't have a b squared. Let's remember, let's go back to our monomials. If I was to do the square of a square, would that not give me b4? Okay, very good. What's the square root of 16? So now what's my two terms going to look like? Now I'm not done. This one, because he has a plus, is done right now. This one is not. He's a difference. Is this a perfect square? Is b squared a perfect square? Yes. Is 4 a perfect square? Yes. Does everybody agree that that's b squared and that's 2 squared? So can I not break this one down again? B minus 2, b plus 2, and I've still got my b squared plus 4. Because that's not a difference of squares. Okay? I can't, logically what some people's going to think is, let's go down here and make this b plus 4 and b plus 2 and b plus 2. They're both perfect squares, but let's do our FOIL. Okay? If we do our first, we get what? B squared. If we do our outside, I get 2b. And it's a positive. Inside is a positive 2b. So now what is 2b plus 2b? Do I have a 4b up here anywhere? Nope. So see, that's why that cannot be broke down. Okay? The difference of squares works because when you FOIL, your outside and inside terms cancels off and you're only left with your first and your last. Okay? So that's why the sum of your squares do not work. Okay? Alright, let's look at another one. I want to pause it, do that one.